So most of these, when you have both the trig function and the inverse, we start out drawing a trig function, or drawing a triangle, sorry, can't write and talk at the same time. So when we draw our triangle, why do we not need that on this one? What's different? Yeah, if you look at like 4, 6, and 7, those required a triangle. What was different about number 5? Yeah, so if we look at, can I do number 4 just for fun? Can I talk about it? So this one was tangent of arc cosine 3/4. Okay, the inside was an inverse, and we know the answer to an inverse is an angle, right? So this was just saying find tangent of that angle. Now, did we actually know the angle that made cosine equal 3/4? No. So what did we do? Triangle. Cosine inverse could be 1 or 2, but because it's positive, it was quadrant 1. You did cosine, so that's adjacent over hypotenuse. How did you find your missing side? So you get 16 minus 7, it's a positive, so we get the square root of 7. So then tangent, opposite over adjacent, was radical 7 over 3. Now 5 is similar, but if I look at the inside, this one isn't an inverse, is it? It just says, what is the tangent of pi over 4? And don't we know the tangent of pi over 4? Yeah. That's the same as saying, what's the tangent of 45 degrees? So think about your hand trick. Tangent square root of the top over square root of the bottom. So radical 2 over radical 2 is 1. So sine inverse of 1 means tell me the angle that makes sine equal 1. If you think about your unit circle, sine is the y. So when is y equal to positive 1? Pi over 2 or 90 degrees. The directions didn't say degrees or radians, so you could do either. Is that okay? So problem 6. There are actually 2 ways of doing this one. So you start on the inside. We know the answer to an inverse is an angle, right? And we're just asked to find sine of that angle. Do we know the angle when cosecant is negative 2? We actually do. Now, if you didn't catch it, I'm going to show you another way to do it. Okay, so if you did a triangle, you're not wrong. But if you caught it, cosecant is the reciprocal of sine. So cosecant inverse, it could be quadrant 1 or 4. But because it's negative, we know it's quadrant 4. If cosecant is 2, that means sine is 1/2. When is sine 1/2? 30 degrees. So 30 degrees in quadrant 4 is 330. And then you just have to find the sine of 330 degrees. So in quadrant 4, sine is negative. Sine of 30 degrees is 1/2. And so I know at least a couple people did it that way. The other option, if you didn't recognize that you knew this, well, cosecant inverse could be in quadrant 1 or 4. The negative puts it in quadrant 4. Cosecant is hypotenuse over opposite. So the opposite side would get the negative. Pythagorean theorem. So this side would be a positive, so you get the radical 3. So then you just have to find sine from that angle. So sine, opposite over hypotenuse, we still get negative 1/2. So if you recognize the angles, great. If not, triangle still works here. Number 7, you also had to set up a triangle for. Is there anything else on the first page that you guys want me to talk about? So then we got into equations. First ones I asked for the solutions between 0 and 360. So this one, we could get our cosines on the same side. Both of these have a cosine in it, so what would you do? Cosine cubed, if you took out a cosine, that leaves cosine squared. Cosine divided by cosine is 1. Then what? So this one you do square root with that plus and minus, so we get positive and negative. So theta equals, when cosine is 0, so if you think about your unit circle, cosine is the x, so x is 0 here and here, so that would be okay, when cosine is positive 1, so when x is 1, that's 0 degrees. And when is x negative 1? Is that okay? Number 10. What would you do here? And then what do we do? So that gives us cosine minus 1. Okay, set each one to 0. So we get sine 3 theta equals 0 and cosine 3 theta equals 1. What does the 3 tell me? Alright, so 3 theta equals, when is sine 0? So if you think about your unit circle, sine is the y. When is y 0? At 0 and 180. When is cosine 1? So when is the x 1? 0. And we already have it, so we don't have to write it again. Okay, so then to get theta, we have to divide each of those by 3. So we get 0 degrees, 60 degrees. We said triple solutions. We have 2, so if you triple that, we need 6. So to do it, we found our period. Normal period is 360 divided by the coefficient of your variable, which was 3, so we get a period of 120. So 0 plus 120 is 120. 120 plus 120 is 240. 60 plus 120 is 180. 180 plus 120 is 300. So that gives us our 6 total solutions. Is that one okay? Number 12. What do you do first? Okay, you subtract that over. Now when you do this, it's not changing the angle. You're subtracting the coefficients. So 3 minus 1 is 2 sine of x over 2 equals a negative radical 3. And then we can divide by that 2. sine of x over 2 equals negative radical 3 over 2. Quadrants. When is sine negative? Reference angle. Still in degrees. When is sine radical 3 over 2? 60 degrees. So our angle, x over 2, equals 60 degrees in quadrant 3. So 180 plus 60 is 240. In quadrant 4, 360 minus 60 is 300. Then what do we do to all of those? To get x by itself, you have to take it times 2, so we take each of those times 2. So you get 480 and 600. Now those are valid solutions, but the directions said, give me all the answers that fall between 0 and 360. These don't, so it's no solution. Not saying this equation never works, but it doesn't work between 0 and 360. Is that okay? Number 13. Okay, I don't have any like terms. I don't have a greatest common factor. So what else can I do? Look at your flip chart. So our fundamental identities, we have those Pythagorean identities. And there's one that says tangent squared plus 1 equals secant squared. So I can replace that secant squared. Tangent squared plus 1. So if I reorder things, I have tangent squared theta over 2 minus tangent theta over 2. If I subtract my 3, 1 minus 3 is negative 2. So then this should factor nicely. Tangent squared breaks into tangent. The angle doesn't change. What multiplies to negative 2 and adds to negative 1? So if we set those equal to 0, we get to here. Right. Tangent is positive in quadrants. Reference angle. Do we know when tangent is 2? No. So you use your calculator. Grab a calculator. Should be in degree mode. Then we just do tangent inverse of 2. You get 63.43 degrees. So, my angle was theta over 2. In quadrant 1, the reference angle is your angle. How do I put that in quadrant 3? Right, tangent negative, when does that happen? Reference angle, we don't need a calculator for that one. When is tangent 1? So 45 degrees in quadrant 2. 180 minus 45 is 135. In quadrant 4. Alright, so then we have to solve for theta. So what do? Multiply everything by 2. So 4 answers, take them all times 2. So we get 126.86 degrees, 46.86 degrees, 270, and 630. All right, but what's wrong? Right, directions say give me the answers that fall between 0 and 360. So that's the 126.86 and the 270. If I hadn't specified it had to be 0 and 360, you would have given me all of them. What are we doing this one? And then what do we need to do? Flip the slide. So we get cosine squared x minus 3 cosine x plus 2 equals 0. So what multiplies to 2 and adds to negative 3? Okay, but then we start out multiplying by 2, so now we divide those by 2. Now what do we do? Okay, so set those equal to 0 and you get cosine to equal positive 1 or positive 1/2. So when is cosine 1? Cosine is the x. When on your unit circle is x1? 0. We are in radians now. Okay, cosine is 1/2. In which quadrants is cosine positive? 4. Reference angle, when is cosine 1/2? 60, which is pi over 3. So pi over 3 in quadrant 1 is still pi over 3. Quadrant 4, that's 5 pi over 3. Were you guys okay on problem 15? Let's look at 6. So what do we do? And what does it become when you do that? So we're trying to solve the sine. So we get sine of 3x equals negative radical 2 over 2. So first of all, the 3 tells me what? Okay, quadrants. When is sine negative? Reference angle. When is sine radical 2 over 2? And in radians, that is? So, my angle, 3x, can equal pi over 4 in quadrant 3 is 5 pi over 4. In quadrant 4, 7 pi over 4. But now what do we do? Divide them both by 3. So we get 5 pi over 12 and 7 pi over 12. But we said triple solutions. We have 2, so if I triple that, we should get 6. So the period of this, Normal period is 2 pi, divided by the coefficient of x is 3. So we have to add 2 pi over 3. So 5 pi over 12 plus 2 pi over 3, 13 pi over 12. We have to add it again to get the next one. So that would be 21 pi, that reduces. 7 pi over 4. Okay, 7 pi over 12 plus 2 pi over 3. Be 15 pi over 12, so 5 pi over 4. Plus 2 pi over 3 is 23 pi over 12. So those are the 6 final solutions. And you can do a quick check. 23 over 12, that's still smaller than 2. So it is between 0 and 2 pi, just like we did. Does everybody understand when you have to get double or triple solutions like that, and you understand how I'm getting them? Okay. One more. Let's look at 17. Right, the sign is already by itself. 2x tells me what? Okay, quadrants, when is sign positive? Reference angle, do we know when sign is 1/4? No, so we have to use the calculator, put it in radian mode. Since you're looking for an angle, you type it in as sine inverse 1/4. We get 0.2527. So x could equal, in quadrant 1, your reference angle is your angle. How would I put that in quadrant 2? Pi minus that. Okay, then what? You may have some rounding error on these, so if you have it, but your very last decimal is different, that's likely what it is, because we're rounding in a lot of different spots here. Alright, so we said double solution, so we have 2, if we double that we need 4. To get it, we add the period. Normal period 2 pi divided by the coefficient of x, and we just get pi. So then you have to do pi plus each of those solutions. And we get our final. Are there any on the test that I did, or on the test, on the study guide that I did not work out and you would like for me to?
I do have a question.
Yes.
So, within quadrant 2 and some radians, you said subtract it from pi.
Yes.
So within quadrant 3,
Then you would add pi.
pi.
So the first question, when you look at these, it's an inverse. So that tells me I'm not dealing with every quadrant. Secant inverse can be in what quadrants? Which one are we in? Okay. So this means secant of some angle is -2, or if you prefer, that means cosine is -1/2. When is cosine 1/2? Reference angle is pi over 3, so in quadrant 2, that'd be 2 pi over 3. Or those of you that like to fill out your circle, you're looking when x is -1/2 in that quadrant. B, arctan can be in which quadrants? reference angle, or sorry, which of the two are we in? Reference angle. When is tangent radical 3? 60 degrees, which is pi over 3. So to put that in quadrant 4, it would be 5 pi over 3. Are A and B okay? Number 2, what would I do first? And then what? So we get sine x equals 1, sorry, minus 1, and 2 sine x plus 1. So when you set those to 0, sine is equal to 1 or negative 1/2. When is sine equal to a positive 1? 90 degrees. Okay, quadrants. When is sine negative? Reference angle. When is sine 1/2?
30 degrees.
So 30 degrees in quadrant 3. So 180 plus 30 is 210. And quadrant 4, 360 minus 30.
350.
Is that one okay? What if I said all possible solutions? What would change? You'd have the 360K on the end. Good. Alright, B. What do you have to do for that one? Cosecant squared is equal to what? So then you can get everything on one side. So it's cotangent squared 2 theta minus 2 cotangent 2 theta plus 1. So that factors into cotangent 2 theta minus 1, cotangent 2 theta minus 1. Since it's a 2 theta, what does that tell us? Alright. They're both the same, so we really only have to solve one of them. So quadrants, when is cotangent positive? 1, 3. Reference angle, when is cotangent 1? 45 degrees. So 2 theta equals, in quadrant 1, that would be 45. Quadrant 3, 180 plus 45. And then what do we do? So we get 22.5, 112.5. Am I done? No, the 2 theta meant double solutions. So what do we do? 360 divided by 2 is 180. So if we add 180 to each of those, I'm going to throw one last problem up. Is that okay? Sorry. What if I said find the sine of cotangent inverse negative 4? You can't do sine of negative 4. We can do, yeah. This inverse represents an angle, and you have to find sine of that angle. We don't know when cotangent's negative 4, so we do a triangle. Cotangent inverse can be in which quadrants? 1 and 2. Since it's negative, it's quadrant. Okay, cotangent is adjacent over opposite. And find the missing side. square root of 17. So sine opposite over hypotenuse would give us radical 17.